Alright guys, welcome to lesson 8.5. I didn't put a what we're going to learn on this one because the title kind of says it. We're just going to learn how to solve exponential equations without the use of a calculator. Before we do, thought we'd go over this really quick. We're going to be making use of this table quite a bit today. You want to be aware of what some really common powers are that are going to be useful. You might want to make a little change on your notes. This one here is supposed to be a 5, not a 4. But anyway, like 2 to the 8th power is 256 and so on. I'll let you guys just be aware of that. We're going to be making use of that today. Let's go ahead and move on over here. So this is an exponential equation right here. An exponential equation is where you have an exponential function, meaning an expression where the input variable is in the place of the exponent. And our job is to solve for x. Now, some of you guys, I would encourage you to try to mentally do this. Sometimes you might be able to. Some of you guys might be tempted to think, oh, it's 2. That's wrong. 4 to the second power is 16. It's not 8. So what would that x be? We're going to figure that out. And so here's the steps. Step 1 is going to be to change the bases on each side into a common base. So for instance, here we have 4 and here we have 8. Those are the two bases that we're currently working with. Well, let's go back to our last slide here. I see a 4 here and an 8 here. When you find the two numbers in the same column, their common bases are going to be what you see here then. So I'm going to change the 4 into 2 to the second power, and I'm going to change the 8 into a 2 to the third power. So let's go ahead and do that. So the 4 becomes 2 squared. So instead of 4 to the x power, now I've got 2 squared to the x power. And the 8 becomes 2 to the third. So I got the bases on each side to be the same. I got them both to have a base of 2. Okay. Now sometimes you'll have to simplify after that. So in this case, notice I have 2 squared being raised to the x power. We can just multiply those together. And so that's going to end up giving me 2 times x is just 2x. Now, since this is an equation, anytime you have an equation, if you have the same thing on both sides, you can just ignore that piece. So for instance, the bases here are the same, so I can just ignore those in a sense. And really all I need to do is pay attention to the exponents. So what we're going to do is just set the x, since I got the bases to match, we don't care about those anymore. We could just make the exponents equal to each other. So now I'm just going to do 2x equals 3, and then from there you're going to solve it. And so my final answer there is going to end up being 2/3. Okay? So those are the steps. Change them to match, simplify, set the exponents equal, and solve. So let's go ahead and do a couple of examples there just to kind of continue bringing this to life. Let's go ahead and do number 1. So I've got 5 to the x power equals 625. So look back at that chart I gave you of all the common powers. Do you see a column that has both a 5 and a 2 or 625 in it? Yeah, it's the 5s, right? So this side's just going to stay as a 5, but this one over here, I'm going to change that to be 5 to the 4th power. So that's my first step. The next step is to simplify, but there's no simplifying that needs to happen on this one. So at this point, we can just ignore the bases and set the exponents equal and solve, and we're done. We've got x equals 4. So that's it. Basically, make the bases match, ignore the bases after that, and solve what's left. Let's go ahead and take a look at number 2. On number 2, I've got 36 and 216. Now, looking at your little chart there, look for a column that has a 36 and a 216 in it. If you look carefully, you'll see that those are the 6s. That's the column with the 6 powers on it. This side is 6 squared, and this side over here is 6 to the 3rd power. So instead of 36, I've got 6 squared, and instead of 216, I've got 6 to the 3rd. But we still have that x power there, and we're going to simplify by multiplying the 3 and the x together. So now I've got 6 squared is equal to 6 to the 3x power. After that, we can just ignore the bases and set the exponents equal, and then solve for x. And so I end up with 2/3. Let's go ahead and take a look at number 3. Number 3 looks a little bit more complicated. It's not all that bad. So we have 81 raised to the power of 2x minus 3 equals 27 to the 4x plus 5. Okay, so let's look at our table and see if we can find which column has an 81 and a 27 in it. Hopefully you're noticing that it is the 9 column. So 81 can be rewritten as 9 squared. Oh, I'm sorry, actually, it's not the 9 column. There is no 9 column, my bad. It's the 3 column. 81 can be rewritten as 3 to the 4th power, and 27 can be rewritten as 3 to the 3rd power. So now I've got these matching bases. But now we need to simplify. And what you're going to do when you have an exponent that's like this, it's like a binomial, you're going to distribute the 4. You're going to multiply it by both pieces. So this is going to become 3 to the 8x minus 12 equals 3 to the 12x plus 15. And after that, we can just ignore the bases and set the exponents equal to each other and solve what's left. So using some basic algebra, I know that I would put the x over here. That would give me 4x plus 15 is equal to negative 12. Then I would subtract 15 on both sides. And that would leave me with the following. I'd have 4x on the right side. On the left side, I would have negative 27. And then finally, division by 4 on both sides will give me my final answer of negative 27 fourths. Okay. Let's go ahead and do one more here. Let's do number 4 just to kind of drill it home. So we have 256 to the x power is equal to 16 to the 2x minus 10. All right, so what column has a 256 in it, and it also has a 16? That's going to be the column with a 2 in it. So 256 is 2 to the 8th power, and 16 is 2 to the 4th power. So now I've got these common bases. We need to simplify. You're going to multiply those together, so you get 8x. And then you're going to distribute this 4 into these two here, and you're going to get 8x minus 40. We're going to drop the bases off, and then we're going to set the exponents equal to each other. And then we're going to solve for x. Now, something odd will happen here. You end up with 0 equals negative 40. And anytime in math when you get a statement like that that's just false, that means there's no solution. So we didn't get an x value. The x is just canceled out, and we ended up with a false statement. Now, sometimes when the x is canceled out, you can end up with a true statement. Like, let's say you get 5 equals 5. Well, if you got that, that means it's all real numbers. So you could write that instead, but that's not in this case. Just giving you some heads up that could happen with your problems. Let's go ahead and have you guys try a couple here. Go ahead and pause the video and try these two. When you unpause it, you'll see the solutions. All right, so for the first one, you should have gotten 2/3, and for the second one, you should have gotten 1. So I'll let you go ahead and study these for a second. So pause the video if you need to. Otherwise, we're going to go ahead and move on to our next example. So in example 2, I want to show you another thing that'll come up here and there is where your bases are fractions. So how do we deal with that? Well, we're going to deal with it like this. We're going to change our fractional bases into whole number bases by taking the reciprocal and giving it a negative exponent. We learned a little rule a little while back, and that rule is that if you have a number being raised to a negative power, all that does is causes it to become a reciprocal. So what we're going to be doing is we're going to be moving from here, from a fraction, to here, a non-fraction. Okay, so that's the goal. Let's go ahead and apply that. So the first thing I'm going to do is I'm going to change this left side here to become 32 to the negative 1 power. And then I'm going to change this side to become 8 to the negative 1 power. So that's how we're going to handle those. Now, before I go any further, I'm going to go ahead and distribute this negative really quick. So now I've got 32 to to the negative x plus 3. And I've got 8 to the negative 2x minus 5. After this, we're going to solve like usual. So there's really nothing new at this point. We're going to solve it like we have been. We're going to change the bases so that they match. So what base can be rewritten as a power that gives me 8 and 32? Well, that would be 2 to the 5th power for 32, and for 8, that would be 2 to the 3rd power. And then we're just going to go ahead and distribute that into the exponent once again, and that's going to give us the following. We're going to have 2 to the negative 5x plus 15 on the left side, and on the right side, we're going to end up having 2 to the power of negative 6 minus 15 on the right side. And then we can drop the bases and just make an equation out of the exponents and solve. So the rest of this is all just business as usual. We've already done tons of these already today. I'm not so worried about these steps as I am about the first two. The first two steps here were the ones that are really important. I want to make sure you got. So let's review those really quick. The answer is negative 30. What do? The first thing you do is you're going to change the fraction into a whole number with a negative exponent. Then you're going to distribute that negative 1 into the power, and then from there you just solve it like usual. Okay, so those are the key steps to pay attention to. Let's go ahead and have you guys try one. All right, so there you go. Go ahead and pause the video, give this one a try. When you unpause the video, you will have the solution. All right, so you guys should have gotten negative 8/3. I'll let you guys check your work here. I started with my first step there and worked my way down and then to the right. All right, let's go ahead and move on to our next one. All right, let's take a look at example 3. What happens when you have a radical in your base? Well, the way we're going to handle that is by using an old rule we've already learned. We're going to change the radical into a power using this little rule here. So we don't have a power out here like this one does. That means it's just a 1. So you can assume there's a 1 there. But basically, the first step we're going to do this, we're going to change this to 9 to the 1 over 3 power equal 3x. After that, we'll just solve it like usual. So what power has a 9 and a 3 in it? Well, that would have to be the 3's. So 9 is 3 squared, and 3 is just 3 to the first, so we'll just put it as 3. Simplifying, we can put those together. We can get 2/3. So I've got 3 to the 2/3 equals 3 to the x. We can ignore the bases and set those powers equal. 2/3 seems to be a pretty popular answer today. I don't know if that'll always happen, but let's go ahead and throw some at you guys here. Go ahead and pause the video here and give this one a try. Now you'll notice this one has a fraction as a base, so we've talked about how to deal with that in example 2, but it also has a radical in the base, which we talked about in example 3. And don't forget, if there's no number here, that's a 2, and the one out here is a 1, so that might be helpful to you. So go ahead and pause the video here, see how far you can go, and when you unpause it, you'll see the solution. All right, so I'll let you study this, but I get up to here. I didn't quite finish it yet. For this one, you might have been a little bit confused. How do you divide 2 over here? Well, whenever you divide a fraction by a number, you basically can just multiply that to the bottom and have your final answer there. So that it's going to be negative 1/4. Another way you could solve it is by doing what we've done in the past many times, which is get rid of the fractions. So, if we started off by having 2 to the x equals 1/2, we could have just multiplied both sides by 2 to cancel that one out, which would give you negative 4x equals 1, and then you could just divide. But so long as you're just following the rules appropriately, you should end up with negative 1/4 either way. Let's go ahead and move on to our last example. So you'll notice that this one is different because because on every other problem we've had one thing on this side and one thing on the other side. But For these problems, there's two things on this side and one thing on this side. Same thing over here. There's two things on this side and one thing over here. And these are problems where we're going to have to combine those things together. Now, I'll show you what I mean by that. So the first step, though, actually, we do want to start by just getting all the bases to match. So look at my bases here. I've got 25, 5, and 125. What's the common base out of all those numbers? It would be 5, right? 25 is going to be 5 squared. And we'll just multiply that with the x. This 5 is going to stay the same. It's not going to change. And the 125 is going to be 5 to the third power, right? So we get all those to have a common base. Now, what's the next step? I didn't want this one to appear yet. I'll go ahead and hide it for now. We'll come back to it in a minute. Let's look at this side, though. If you're multiplying, which we are in this case, we're multiplying, add the exponents after making the common base. So I made the common base. Now I'm going to add the exponent. So I'm going to add this exponent to this exponent. So you're going to get 5 to the 2x plus 2x plus 1. Right? Which is going to give me 5 to the 4x plus 1. And then the problem after that is pretty much the same. Okay, so you drop these bases and you'd solve this equation. If you subtract 1 and divide by 4, you're going to end up with x equals a half. I'm not going to show my work for that, but there it is. I do want to talk about why this works. You guys remember, you don't need to write this part, but I just want to teach it to you really quick. You guys know the rule x squared times x to the fifth. What would that be? Well, you would add their exponents, right? So anytime the bases match, you can add their exponents up to get a bigger exponent, right? So 2 plus 5 is 7. Same thing here. Since these bases are the same, you can add this exponent to this exponent, and when you do that, you get 4x plus 1, right? So let's go ahead and take a look at the next one. Now on this one, I'll come back to that in a second. Let's review another old math rule. If you have, just a minute. If you have x to the fifth divided by x to the 2, what do you do in that case? Well, you subtract them. You do the top number minus the bottom number, which is going to give me 3. Okay, that's an old exponent rule. Well, we're going to do the same thing on this one. Okay, but once again, the first step is to get all the bases to match, because you can't apply that exponent rule until all the bases match. So for this first one here, we're going to go ahead and see, look at our bases. I've got 100, 10, and 10,000. This is a little confusing. I meant this minus 3 to be in the exponent, so just keep that in mind. But anyway, 100 is 10 squared, right? So that's going to be 2 to the x, or 10 times raised to the power of 2x. 10,000, that's going to be 10 to the power of 4. And this one down here on the bottom is not going to change because it's already a base of 10. Okay, now what do? Now we're going to apply that rule. Okay, and the rule was to subtract the top minus the bottom. So it's going to be 10 to the top minus the bottom. Now you'll notice that I put the bottom 2x minus 3 in parentheses because we're subtracting the entire bottom, not just the first part, but all of it. In other words, you're going to distribute this negative here and subtract both pieces. So that's going to give me 10 to the 2x minus 2x plus 3. Now you'll notice these 2x's cancel out, and I'm left with 10 to the 3 is equal to 10 to the 4. The bases match, and I'm left with this, which is a false statement, and as you guys might recall, that means no solution. Okay, so the strategies are, as you guys can see here, when you're multiplying, after you make a common base, you add the exponents together, and if you're dividing, you'll subtract the exponents after making a common base. And that's the gist of it. So let's go ahead and have you guys do one last student practice, and we'll call it a day here. So go ahead and pause the video. When you unpause it, you'll see the solutions. So here's the solution to the first one. I changed the 9 into 3 squared and the 81 into 3 to the 4th. Then I distributed the 2 into the x minus 5. And then I applied the rule. Now that I got all the bases to match, we can add the 2x minus 10 to get 3x minus 10. And then we could drop the bases and make the exponents equal and solve, and you should get 14/3. Let's go ahead and take a look at the second one now. All right, so let's go ahead and take a look at this one. First thing I did was I changed a 36 into a 6 squared, and I changed the 216 into a 6 to the 3rd power. Next, we simplified by multiplying these together to get 2x. Then I applied the rule, which is when you're dividing, you subtract top minus bottom. So I have 2x minus x plus 4. And then I'm going to go ahead and distribute this negative once again. So that becomes negative x minus 4. Then we simplified. 2x minus x is 1x. Now it looks pretty standard, so we drop the bases and make an equation out of the exponents and solve. You should have gotten 7 as a final answer. And that'll do it. So hopefully that was helpful, and we'll see you guys in class.